Cool. Hello, everyone. Welcome to week 10 of SEC1337. This is going to be recorded on another device with higher quality, so don't mind the fact that you can barely see what is going on right now. It's because I don't have my proper webcam set up, but don't matter. Like I said, this will be sent out as a more high quality video here in just a tiddly bit. So this week, it's week 10. We got 6 more weeks after this, and we're going to be talking today about enterprise IT security. So what is that? Well, it is a domain that's focused on securing the assets, resources, and applications that employees consume internally, not customers. We're really focused on protecting the things that the employees need, because the employee security is, essential, to protecting the business. If we can't protect our employees, we can't protect anyone. So there's a lot of different areas in which we need to focus to really cover our bases with enterprise IT. So the first thing we're going to talk about is what's called user lifecycle provisioning. This is the whole process of figuring out onboarding, bringing new employees on, transitioning in the event that employees change role, team, company, and then offboarding. We have to make sure this process is automated and secure. We don't want a situation where an employee leaves the company and still has access to our code repo. We don't want a new employee that starts and can't access things or has a default password assigned to a machine that happens to get stolen, and a number of things. So we need to make sure our workflow is automated and free of error, and we have to consider security along the way. When we look at an onboarding workflow, really it can be distilled down to 6 steps. The first is HR will add the employee. After the background check, they'll add it to what's called their human resources management system. An example would be like Bamboo, Workday, or whatnot. Once the employee info is in there, we have some automation define it, send it to what's called our identity provider. A couple examples are Okta, Azure. Our identity provider is like our central hub for managing users, identities, applications, and so on. Once that gets to our IDP, the IDP will assign the employee to groups based off of role-based access control, which we talked about in week 1. That is the principle of assigning apps based off of what the user does, their team. We want to enforce least privilege. We only want to give them enough access to do their job, no more, no less. And similarly with applications. So once we assign RBAC, IDP kicks off a workflow. It'll map the groups the user is in to the applications they're supposed to be assigned to. Pretty straightforward. If they're in the engineering group, they'll get GitHub. If they're in finance, they'll get QuickBooks, so on and so forth. Then the 5th step is the employee gets provisioned in the actual app. So IDP, the user exists, they get assigned to apps. The app itself, Salesforce, Azure, whatever it may be, actually needs to have the user. And there's a couple of methods. One is called SCIM, software for cross identity management. That's an ideal way. It essentially uses an API called automatically provision, in real time to the app. There's another method called just in time, JIT, and that works by the user logs in and then it's created. So there's basically like an entry that's mapped, but the user isn't entirely created in the target app until they log in. And then the third is like manual API calls if we don't have this first 2, but it should be automated. And then the last step is the employee will log into the IDP like Okta. They'll have all their apps in one place. This is called single sign-on. They'll find the app, Office 365. If everything goes well, they click it, logs them into the app, they get access, bada boom, bada bing. That's how onboarding should go. Transitioning, there's just a couple steps here. So not 6. We just have to do a couple things. So if we transition, if the user all of a sudden changes teams, well, you can kind of see where this picks up. We basically jump to group step 4, which now becomes step 1. Once we So, well, really, here's what happens. HR will change the status of the employee in their HRMS. So let's say that they're a distinguished security engineer and they decide for some reason to move to marketing. Well, HRMS will update the employee info. So step one, HRMS. This is for migrating or transitioning or migrating. Good workflow. Transitioning HRMS updated with the info. The employee info should be the same, except their title and their team will change. Then it goes to the IDP. IDP updates the groups based off of the title and department. IDP provisions, the new apps, so on, and then skim and then that. But there's another step. Part two is we have to deprovision the apps that they no longer have access to. So this kind of splits off. So the IDP actually is going to look. So when it drops and adds the groups, so it adds to the groups, and then the groups that it drops, it'll then go into the deprovisioning workflow and kind of do the opposite. But that's actually step three. So let's talk about offboarding or deprovisioning. So when that happens, as you can probably guess, it's the reverse of onboarding, but it's way more important that we get this right because there are a lot of security snafus that can happen, and I've seen happen when onboarding isn't done properly. So essentially what we do, again, this is actually reverse though. Before we kill it in HRMS, we have to kill it in the IDP first because then it flows backwards. So when we go into, say, Okta, we deprovision, we disable the user. When that happens, we should have automation that then goes, okay, remove them, or look at the groups they're in, look at the apps they're assigned, go into the apps and deprovision their access. So be it SCIM, JIT. Well, JIT isn't going to work for deprovisioning. It has to be SCIM or an API. So SCIM is ideal because the moment they're deactivated in the group, it automatically deprovisions from the app. Where people get in trouble is apps that don't support SCIM, which are a few. You have to still manually do with an API, and a lot of people don't understand APIs. They're not that hard, but if you don't have an automated way to do this, you're going to have a bad time. The good thing is Okta has advanced workflows, and they help you build API connections. Times is another great tool for doing this. There's a lot of ways, but again, security is hard, and you don't know what you don't know. Now you know. So once you deprovision from the apps, you remove from the groups, and the user's disabled and eventually deleted, but you want to hold on to the user for compliance, typically for like 6 months to 12 months after the fact. And that's offboarding. So that's user lifecycle provisioning, and it's really important that we get this right. So that's what I'm going to talk about there. Now we're going to talk about our endpoints, right? We had a kind of a section where we're talking about endpoint security, but this is our second focus within IT security. So our user lifecycle provisioning, that makes sure we get our employees off, cartwheeling, hitting the ground cartwheeling, and make sure they're successful throughout their career, be it whether they stay in their role, they change, and also make sure that we revoke access and deprovision properly when and if they leave. So endpoints are likely the second most important target here. So the endpoints are the workstations, the laptops, the phones, any of the devices the users interact with. And there's two different categories. There's company managed, like corporate issued assets, and then there's what are called BYOD, bring your own device. They're both critically important. A lot of companies that are myopic only worry about corporate assets, and they have this silly misconception that, employees will only use company assets to do work. Wrong. It's 2024. They're going to use whatever device they want and have, so we need to be prepared for that scenario. So how do we tackle this? Well, let's say if we had the benefit of a managed asset, we want to add our typical controls, which are, we need next-gen AV, which we talked about at a minimum. That includes endpoint detection response. We need both. So CrowdStrike, SentinelOne, Bitdefender, that's running. That's kind of our base protection. We need heuristic-based, which is next-gen AV, that's signatures, and we also need anomaly-based, it's EDR. So that's kind of like the foundation of endpoint security. We also need what's called DNS security. It's, DNS is domain name system, and basically our DNS security will block malicious domains. It'll protect the user against various types of DNS attacks. So some of the next-gen AV either have it, but commonly not. So you kind of have to look at some things like Cisco Umbrella or Cloudflare, or whatever it's called. Or if you want to manage it yourself, you can point or you can enforce that everyone connects to specific DNS servers that are built for security. Cloudflare runs 1, 1, 1, 2, and 3, and 1, 0, 0, 2. Those DNS servers are designed with DNS security malware. There's also there's actually things you can do with push security, which we'll get to. So you don't necessarily need an endpoint, but we can't rely on our network security with our firewalls. Again, the corporate perimeter is gone. With the cloud, people have access to data everywhere, anywhere, on any device. So we can't just hope that they stay in the office and be canon. That's not realistic. It's not how people work these days. So DNS security is important. But then now this is really where we have to understand how to protect corporate assets and BYD. We use this thing called device hygiene. So, give you an example. Duo is a perfect example of this. That's what it supports it. Duo allows you to define policies that grant access. For example, we want our device at a minimum to be OS patched, running the latest browser, not running JavaScript, encrypting the disk, using BitLocker, having a host firewall. We can look at a variety of different controls, and the beauty in this is that we don't need to install an agent. We really just need, in the case of Duo, the Duo app itself runs the device hygiene, which is brilliant. And similarly on the device, all you need is a browser to get all this telemetry. It's amazing. So any device that hits a Duo protected app, for example, automatically sends device context info, and then we can make decisions based off that device's hygiene. Are we going to grant access? If so, to which apps? What are we going to allow them to do? On bring your own device, situations, we probably, we're going to let them use Slack, Gmail and stuff, but if we really want to protect important assets, that's where we can add device context and say, for example, if you want to get the GitHub, you do need a company asset with certificate authentication. And this is where we can get fine-grained policies. This allows us to find the right balance of usability and security. You have to look at the modern world, which a lot of companies don't understand. Like I said, they just assume that people are going to use work computers for work things. That's not realistic, because how do you manage phones, tablets, personal computers? These are all BYOD, and device hygiene's the best way to protect it. It's the best way to have balance. And that's really important. That leads to contextual analysis. Contextual analysis will evaluate in real time and make a decision. So we want to look, and we can add different parameters too, like IP address. Is it a one that we're expecting from the user? Is it a new one? What time of day are they logging in? If things are anomalous, we can use our IDP to block connections until we say require another MFA push or something. So this is really helpful. This is how we protect in the modern world. That's what works. There's another layer of protection though. We want to ensure that we are managing our administrative accounts. If you look at the major reasons that breaches happen, there's really three themes here. And if there were anyone in the real-time audience, I would ask them, but this is what they are. Credential abuse, passwords, weak passwords, all that shitty shit. Credential abuse is way in. Social engineering, of course, and phishing. And yes, 3 is abusing admin rights. So admin sprawl. You have admin accounts, APIs with users that haven't logged in for years, and they're just sitting there waiting to be, abused. So we need a way to sensibly get admin accounts under control. We use this concept called privileged access management. And Pam, and the way this works is we grant admin access, but only for a brief time for specific apps. So when a user needs admin rights, rather than have everyone be God level admins all the time and expose themselves to being vulnerable and compromised, you say this: okay, I'm an engineer. I need to install some tooling on my machine. I need to elevate admin rights. We'll say for an hour, we'll issue you admin access, and then we'll revoke it automatically. That's how you do admin. It's similar to the hotel security. If you look at it, one of the remediation items I tell them right off the bat is if the maids typically have skeleton key and persistent access to all the hotel rooms with their badge. As long as they have their badge, they have access. The first step you need to do is simply revoke access when they leave, and when they come back, give them access. It's trivial, but it will prevent or make it harder for situations where you can literally just live in the hotel for days using a maid's key. So that's one concept. But similar with this, we also want to extend on this and not only admin rights, but any kind of credentials. So like if we have AWS API keys, what we really should be doing is we should not ever be allowing the user to just use static keys. The static key should then be sent to, say, a secrets management system, which each time, like Vault, HashiCorp Vault, and Vault will literally generate a unique set of keys for each session and then revoke them, using IAM and STS, simple tokenization service. Yeah, Vault does this automatically, but you can use any number of methods to securely manage credentials. So that's really important for PAM. And then one other thing we can do similarly is this thing called application allow listing or whitelisting, blacklisting, but that's so faux pas. Can't say that anymore. Can't say black or whitelist because it's racist. But the reality is, we'll just say allow and deny this. And so the way this works, we have two different approaches. We can specify a list, and we normally have to enforce this on the device with an agent. Again, this is only really going to help for corporate devices. We can't really do this with the LD, but we have allow list. So an app allow list works like this. We specify the apps we allow, and we deny everything else. So maybe we want to allow like Sublime Text, Chrome, whatever, and we deny it. And if users need access to something that's not approved, they'll send a request, usually through PAM. The PAM agent security will get it, and they'll either allow or deny it, depending on the riskiness. That's one way. And then the deny list basically just says, okay, we're gonna allow every app except for the ones we deny. So maybe we don't want people running TikTok because it's Chinese spyware, or maybe we don't want them running BitTorrent, whatever. But everything else is fair game. Obviously, you can probably tell. Allow lists are better for security, worse for productivity. Deny lists are better for productivity, worse for security. It really depends on your company. There's no necessarily right or wrong way to do it. But having some kind of application awareness is key, rather than again letting everyone run everything and you get yourself a Wild West situation. And it's very important at a minimum, every device that we manage and that we can't enforce encryption on UID, but we can write policies to deny access if there is no encryption. But for managed assets, we have to ensure we have full disk encryption. On Windows, we use BitLocker. On Mac, we use File Vault. On Linux, you have other options like Veracrypt and so on. But this is incredibly important because if an asset gets stolen, we need to make sure that the bad guy can't just open it up, get all the data. Encryption protects the disk, and encryption uses a key, but we need to make sure that that key is protected by a strong password. So don't just allow people to put password 1, 2, 3. We need strong encryption. So that's our approach to endpoints, protecting them in a nutshell. I'm in a nutshell. Okay, there's a further concept we can expound on here, sort of in the BOE. Now, sort of, this kind of crosses a couple different domains. It's called mobile device management, MDM. And this is an additional way in which we protect our assets. And how we protect them is I'll give you an example of Mac, because Mac is much more mature in this sense. With Macs, we can set up a policy with Apple. We create in this thing called Apple Business Manager. Whenever we buy a new Mac, we tie the serial number to what's called, ABM. And basically at that point, that machine is under the control of the corporation, meaning if somebody were to take it, steal it, and try to use it, they won't be able to, because it would constantly go back to ABM, because ABM then specifies with our actual MDM. So our MDM, for example, would be Jamf, which is the most popular, Collide, Mosel, so on. And these MDMs are what enforce the policies. So, for example, MDM will say something like disk encryption required, host-based firewall, all these things. But most importantly, this is the sort of checkpoint. If you have a company asset and you're trying to bypass and use it for your own use, you won't be able to, because the MDM will keep kicking back to ABM. ABM will say, okay, you have a managed profile. If you can log into the company account, go for it. And the moment we do that, then we start pushing all the security policies. So far, no one has broken this. Of course, it can be broken. The easiest way to break this is to social engineer Apple, because Apple allows you to put requests in. For ABM, normally they require an invoice, but I've social engineered them and gotten them to unlock machines that they shouldn't have. So layer attacks are still effective. But MDM gives us protection, but it also allows us to automate things and build out what's called zero-touch deployment. So in an ideal world, I've got user lifecycle provisioning. You can see this as the device lifecycle provisioning. The idea is this: ABM, MDM. We have a provider like CDW or SHI that actually sends the assets. The user should open the machine. They log in locally. But when they log in locally, it actually connects to Okta. So that's the beauty with Jamf. Jamf Protect hooks directly into Okta. So the moment they log into their local machine, it syncs their password to Okta, and it immediately gives them access to all their apps. That's all they have to do. I've seen this. It's beautiful. It's wonderful. It's essential for remote employees, because you can't just have IT babysitting machines. You need to have some kind of zero-touch deployment, because that makes things way easier, and it makes it way more secure too. So that's really important. And then there's a concept. This kind of transcends. We talked about this a couple weeks ago. We also need to protect SaaS and identity, and that's where push security comes in. So this isn't specifically related to MDM, but it's its own category. As an IT function, you're responsible for protecting software as a service apps that the employees use. So a couple examples, and this is what flows through Okta. You've got any number of things. You got common things like Office 365 that everyone uses, maybe Bamboo, HR. These are the core applications. Google G Suite, Google, we have especially, teams like GitHub. Engineers use GitHub. They use Trello, Jira, so on. And then you go on. So how exactly do we protect people with all these apps? There are hundreds of apps, many of which are not sanctioned. We can have a list of apps we approve, but we can't be so foolish as to think employees are only going to use sanctioned apps. That's just not reality. And so a lot of the products that tried to tackle this early on, like Casby and stuff, they only really operated by looking at known apps and the APIs. And even when endpoint stuff came around, it would only tell us what was happening on managed endpoints. But the reason push security is revolutionary is you can deploy this bad boy as a browser extension on any device, managed or not, or we can look at social logins. So Google, Microsoft, and the first thing is we want visibility. We know that we can't just stop use, but we can figure out what people are using, from a browser extension and Google alone. So it'll identify, catalog all the apps, And then we can start to enforce policies. We can do things like annoy the user with a Slack message, like, hey, your password's being reused from Okta to Amazon, change it. Or you're using Box. Did you know we have Google Drive we pay for? Why are you using Box? It's not sanctioned. It's called honest security. We're putting the power and the responsibility back on the user rather than security having to come in and try and enforce by beating everyone in the head with a tack hammer, because the tack credit, because that doesn't work. Security by force doesn't work, right? You can't bolt it on. It has to be part of the culture. That's why Push Security excels. Big shout out to Adam Bateman and team for making that happen. And then I think there's one other thing I wanted to talk about, but that is in a nutshell IT security. And yeah. Yes, that's it. So there's more elements, but that's the major concepts you want to know. So I want to open it up to the audience. Any questions, concerns, ideas about IT security?
Yo, yeah. So you had mentioned Apple and social engineering their support to unlock things that maybe they shouldn't have.
Yep.
So I guess that's coming back to the human layer of security, and ultimately some scrub at Apple could just circumnavigate all this other security by just being engineered. And I guess, is there a way to protect against that from Apple's standpoint, aside from more training?
Yes. What Apple should do is have like multiple approvals, right? Because all you need to do is do what's called a device activation release. And so Apple really clicks the button and says, this device is no longer managed by the company. This user has it, right? But often it's only reviewed by one person. It should be like, okay, one person reviews it, you send it up to another person. Is this request legitimate? If maybe it is, but hey, let's see the purchase order, right? We can't just assume this person bought it, or maybe they left the company, they're claiming it's their asset. So any number of things to just verify that they own the asset and not the company. That's really the best defense on the layer 8. But you're right, and that's like anything. If you look at even like crypto, right?
Yeah.
How do you use crypto withdrawals? Like you don't have multiple levels. You should use the whole Shamir key algorithm, where it's like 2 out of 3 keys or 2 out of 3 approvers should be necessary to make a big decision like that, not just one, just like the nuclear codes.
But then from a customer support perspective, though, that's looking like a multi-day kind of approval process.
Yeah, normally Apple says it takes 48 hours, but that's you want to slow it down a bit, but not too much. But it's people to slow it down when you're talking about what could potentially be a valuable asset that may or may not be owned by the person. But Apple has made mistakes, but from a technical standpoint, it's solid. I mean, you can bypass it insofar as block communication to ABM and stuff. And you can totally use an asset that's MDM. But it's going to have limited functionality. You're going to get annoying alerts. Apple did a solid job, but as you know, with any security, if it's built, it can be broken. So
just different layers.
Right. Part of the bug bounty hasn't turned up any major vulnerabilities with ABM itself, just with the people. So as it goes, layer 8, man, it's always effective. I'm sure there'll be some vulnerability at some point on the Apple layer, but it's been around for a couple of years. It's worked fairly well. Now on Windows, not so much. Windows is piss poor with MDM. It's like, honestly, they don't have the same partnerships. Like Intune's the MDM for Windows, but they haven't built that kind of supply chain in the way Apple has for whatever reason. So you don't really see any good examples of Windows being able to manage assets in the same way. And also Microsoft just hasn't taken on the responsibility to build an ABM-ish platform for whatever reason. Windows is definitely more vulnerable for a lot of reasons.
Okay, thanks.
Feel me? How about you? Hey, we're good. Cool. All right. I'm glad we got to teach this. Next week is going to be, how do I say this? Data security, in my opinion, is the least interesting. Not to be hating on people. No, I wouldn't say it's the least interesting. It's really important, but it is very nuanced, right? We're going to be talking about databases. We're going to be talking about messaging, queues, Kafka, all the ways we have to protect the individual data and information. It's really important, but it's also a really hard problem. Like this is probably the hardest problem in security to solve. So it's really important if you want to go next level, but it's totally a class that you can skip if you don't want to do hard things in life, or you don't necessarily. No, I don't want to say. I mean, data security is a really hard problem, and you'll see why when I talk about it. Not to scare you away, but yeah, truth be told, it's going to be the hardest thing to wrap your head around, because data security, it's just there's no real elegant solutions to this day for many reasons. Because the biggest challenge is you want to find a balance of data availability, but also obfuscation. And it's really hard to do that. You want a large enough data set to make decisions, but how do you prevent having too much data about people? You can randomize it, but then you don't get real data. So it's the nature of the problem, right? It's difficult, but there are some new methods that are coming along, like homomorphic encryption and differential privacy, and things that are leveraging quantum computers. So I'll give you a preview of that. But yeah, it's a problem that no one has really solved. Snowflake just got pwned. There's just a lot of companies trying to do data security, and I think it's intractable, kind of like email security. But anyway, not to make you lose hope. But that's going to be next week. And then we're kind of winding down after data security. We're gonna pivot into, I'm gonna consolidate a couple of things. Rather than security architecture and engineering being separate, we're gonna combine them because there's a lot of overlap. And similarly, we're gonna have SecOps. And the last class is actually gonna be about getting a job in security. Because that's really ultimately why a lot of you probably are joining, because you want to figure out how to get into security or get a better job. And that last class is gonna be all about that. Resumes, interviews, where to stay up to date, all the really cool topical shit. So looking forward to seeing you all next Sunday at 2. This class, I kind of moved around just because I was busy, but here it be. So I'll send the recording out here shortly. But thanks as always, y'all. See you next week. Peace.
Thanks.
Yeah, man.
Bye.
Adios.